In this lesson on square roots, it is only appropriate to begin with an explanation on where square roots come from. And the best way to do that is by telling you about perfect squares. Now, perfect squares are the product of an integer squared, so an integer times itself. Here's a visual representation to help you understand that. If I have one square unit, then this is a square in which the length of each side is 1. Now 1 times 1 is going to give you the area of that square. And because this is 1 by 1, this is 1 square unit. And 1 to the second power, 1 times itself, is equal to 1. This expands so that if I had the side of my square expand to 2 by 2, you can see that I have 4 square units here. 2 times 2 is 4 square units. 2 squared, 2 times itself, is equal to 4. So far 1 and 4 are perfect squares because they are the product of an integer squared. 1 is an integer, squared is 1. 2 is an integer, squared is 4. 3 times 3, we have a perfect square here, and you can see there are 9 square units here. 3 times itself is 9. 3 squared is 9. 9 is a perfect square. 16 is a perfect square because 4 times itself is 16. 25 is a perfect square. 36. 49. 64. 81, 100, 121, 144, they're all perfect squares. I'm dropping markers. Hope you're loving it. Anyway, so that is the definition of a perfect square, and it's going to really help us understand square roots. So, what is a square root exactly? Well, the square root of a perfect square is the length of one side of the square with the area equivalent to the value of that perfect square. So if I had a perfect square with an area of 4 square units, they're 2 by 2. Well, we make this square root symbol kind of like this fancy division with a check mark looking thing. The square root of 4, so that's how you would read this here, this expression, would equal 2 because the length of one side of a square with the area of 4 square units is 2. It is the root of the area of the square. Now, if we're talking about perfect squares, it's kind of simple to think about the square roots of perfect squares because they root back to multiplication facts that you should be pretty familiar with. So if I was thinking about the square root of 16, the kind of thing I need to ask myself is, what number times itself is equal to 16? But I have to kind of throw up a red flag for you and say, there is more than one answer to this. Because if we go back and we see that the product of an integer squared is a perfect square, then that means the square root can be an integer. Integers are not just positive numbers. So think about that for a second. Now, what number times itself is equal to 16? 4 times 4 is equal to 16. So we can say that the square root of 16 is 4, because 4 times 4 is 16. 4 squared, 4 to the second power is 16. But isn't it true that negative 4 times negative 4, or negative 4 to the second power, is equal to positive 16, because a negative times a negative is a positive. This is true. So this has 2 answers, 4 and negative 4. That's what I mean when I say, really think deeply, consider all possibilities. Let's talk about the square root of 81. Well, what number times itself is 81? 9. But we also need to keep in mind now that negative 9 times itself is going to be 81 as well. So the square root of 81 is 9 and negative 9. And another perfect square we're familiar with that I mentioned earlier, 144. Well, the square root of that would be equal to 12. And also, because now we're remembering to consider all possibilities, negative 12 times itself would also equal 144. So that means that negative 12 is also the square root of 144. We have two correct answers here. So I want you to think about what the square root of 2 and 2500ths would be. Now, we're not always going to be working with perfect squares. In a perfect world, of course. However, not every number is a perfect square, but every number has a square root. Every single one. So we know that 2 and 2500ths is not a perfect square. We can't off the top of our heads think of two numbers that multiply, two whole numbers, two integers, that multiply to make 2 and 2500ths. But 2 and 2500ths could be the area of a square. It could be 2 and 2500ths miles. Could be somebody's land, square miles. 2 and 2500ths square yards. Could be an area of something. So because it is a possible area of a square, of any size, it must have a square root because there must be the length of one side. So there is a number where if you multiply it by itself, you will get 2 and 2500ths. So let's think about what we know before we even try to attempt this. Now, a lot of times we have a calculator, we can just type in square root of 2 and 2500ths, enter, and it will spit out an answer. But what does that answer mean? It's important to work with it and get your hands dirty so that you care about what it means, so when it pops up on a calculator, you can understand if your answer makes sense or not. So think about what you know. Consider your perfect squares that are near 2 and 2500ths. Well, 2 and 2500ths is between 1, which is a perfect square, and 4, which is a perfect square. We know that the square root of 1 is 1 because 1 times 1 equals 1. And we know that the square root of 4 is 2. Let's think positive just for a moment, because 2 times 2 is equal to 4. So that means that something times itself that equals 2 and 2500ths, that something must be between 1 and 2, because 2 and 2500ths is between 1 and 4. Okay, so this is where we kind of have to play a guessing game, and that's okay. So I immediately, when I say, think of a number between 1 and 2, 1.5. I like working with decimals, so I would say, well, 1.5 times itself, remember, times 1.5. We're thinking about a square, right? So we would have 1.5 by 1.5, and we want to see, does this equal 2 and 2500ths? So 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Come down here, put my 0, I have 5, I have 1. I add, lo and behold, 2 and 2500ths. So what is the square root of 2 and 2500ths? What number did I multiply by itself to get 2 and 2500ths? 1 and 5/10. But don't forget that your answer could be a negative. However, in this case, if you were to draw it, could my answer be negative? The length of the side of something? Is the length of anything ever going to be negative? No. So you'd have to be careful, depending on the kind of question you're answered. Now, if I asked you the possible value of the square root of 2 and 2500ths, yes, your answer could also be negative. But if we're talking about an actual square, it would be impossible. So just think about those things. This is one of those scenarios where your answer won't be able to be negative because it says find the length of one side of a square with the area of 75 square meters. The length. Lengths are distances. Distances cannot be negative. We know this. So we will not be considering a negative part of our answer here, a negative square root, so to speak. If I know the entire area is 75 square meters, I could try to break this up into squares and count the number on one side, but is 75 a perfect square? It is not. And so, I need to consider the perfect squares that 75 is near. I know my perfect squares. Let me think. 8 times 8 is 64. So I know, and I would just do this on my work, the square root of 64 is 8. And I also know that the next perfect square up from that would be 9 times 9, which would be 81. So, there we go. So that means that the length of this square, if the area is 75 meters, must be between 8 and 9. This is where you have to start trying to make sense of it. Immediately, I think of between 8 and 9, 8.5. So I would try 8.5 times 8.5. This is going to give me 25, 42, 40, and 64, 68. I add this up. 72 and 25 hundredths. This is not 75, it's less than 75. Because this is less than 75, the value must be greater than 8 and 5/10. So I'm going to up it a little bit. I would try 8 and 6/10. So then I would move to 8 and 6/10 times 8 and 6/10. 36, 48, 51, 48, 0 is here, 64 plus 4, again, is 68, 6, 8, 9, 8, 9, 10, 11, 12, 13, 73.96. So again, it's going to be larger. Now I didn't increase that much with 1/10 of a growth. So I would maybe try 8.8 next. And it is quite a bit of guessing and checking, but you're really understanding how these numbers work when you multiply them by themselves. So this is 64. 64 plus 6 is going to be 70. Again, 64. 64 plus 6 is 70. Again, 4, 4, 7, 7. Now we are too large. So then where we would go from here, and I'm not going to spend the time doing it, is I would go to 8.7. Multiply that by itself. And then I would move from there. And we'll do some of that in class together. Okay? Now, you'll notice from that example that not all square roots are rational. In fact, that decimal number might extend to a few places. So, it is much more frequent for square roots to actually be irrational. And here are just a few examples. The square root of 2 is 1.41421356, etc., 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 etc. It cannot be written as a fraction, and because of that, it is irrational. The same with the square root of 3. It goes on and on. It is irrational. The first perfect square after 1 that we come across is 4. That perfect square, the square root is 2, and therefore it is rational, and it's also a perfect square. The square root of 5 is also irrational. I just wanted you to notice that when we get near perfect squares, the square roots get closer to those perfect square roots. And it's something that I think would be obvious, but maybe not so much. I want you to make sure that the guesses that you come up with are accurate. So the square root of 25 is 5. So that means that the square root of 24, which is less than 25, must be less than 5. And that comes out to be 4.89897, etc. The same is true for the square root of 26. Now 26 is greater than 25, so the square root of 26 would be greater than 5 because it is a greater value. So what comes out to be true is that the square root of 26 is 5.0990195, etc. So notice that these values are both close to 5, incredibly close actually, but they are not 5. The only square root of 5, or square root value of 5 is going to go with the square root of 25. Okay? It's going to go with that perfect square. Anything surrounding that that's not a perfect square will be probably an irrational value. Okay?